Good afternoon, class. Today we are going to be learning about pedigree. So this is part 5 of Unit 6. Here's our learning target. I can observe how traits get passed on through a family by using a pedigree. And then our bell work question is, what is a biological pedigree? So let's get started. Okay. So in a pedigree, it's a visual representation of a family and traits being passed through a family. Squares will always represent males, circles will always represent females. If the individual is affected by the trait that we're tracking, then their square or circle will be darkened in shape. Sometimes heterozygous individuals, which are hybrids or carriers of a trait, will be half shaded, but not always. Some people do that and some people don't in a pedigree, so you have to be careful of that. Any horizontal lines between a male and female, like here, represent a marriage or mating. And then vertical lines going up and down, drawn from the mating, represent any offspring that are being. So this would be the offspring of these two parents. If there's a V-shaped line like this, it'll indicate that those are identical twins, which means they will have the same genotype for that trait. Pedigrees can only show one trait at a time. They will not work with polygenic traits. Will include a specific trait that is passed in the title, so you know what the colored shapes mean. Make sure, this is an intention here, the trait can be normal traits or diseases. Pedigrees are used to identify how a trait is passed. If a trait is passed, then you can see the possibility that someone in that family is a carrier. Traits shown can be either dominant, they could be recessive, codominant, incomplete dominant, or sex-linked traits as well. Pedigrees can show all of those things as long as it's just a single trait at a time. Autosomal genes are going to show different patterns on a pedigree than sex-linked genes. In autosomal traits, male and females have the trait in fairly equal amounts. But in sex-linked traits, it's typically more common in males. So only females are usually heterozygous. They're usually just carriers. Females can have them in sex-linked, but it's very rare, much rarer. We'll see examples in a bit. So here's an example of a typical pedigree. Now you can see in this pedigree is completely filled out. We can see who are the males, who are the females. We can also see who has the trait. In this case, this trait is a dominant one because anyone who is either heterozygous or homozygous dominant is shaded in, and only the recessive, homozygous recessive people are not shaded in. So this shows a dominant trait. We'll see lots of examples of both dominant and recessive traits. All right, here's a different one. This is a sex-linked trait. You can see here, we actually show the gender of each person. Males, again, have X and Y chromosomes. Females have two X's. So you can see here, this male does not have the trait because he's got a dominant allele. This female technically doesn't have the trait, but she does have one recessive, so she's a carrier. And then you can see here that it's mostly just only males that are getting it. The females can be carriers because they can have these little M's for whatever this trait is. But every once in a while, a male will get that recessive trait. And because they only have that one X chromosome, they're going to show that trait. So that's what we want to talk about. Is it dominant or is it recessive or is it codominant in nature? So this, we can apply 3 pedigree laws, and it's all about patterns. Law number 1, if you have the same parents, but then a different child, then the child will most likely have the recessive genotype. Okay, like in here, you can see here, in some of these cases, one of the parents has it, one doesn't. But if you look at these parents here, 8 and 9, these two parents do not have the trait. Some of their kids don't have the trait, but one of them does. So that lets us know, because we've got same parents but different child, that means this child is homozygous recessive, and therefore anyone else on the pedigree who's shaded in is also homozygous recessive. Here's another one. Now you can see here, same parents. Some of the children have it, some of them don't. So again, same parents, different child. So in this case, this lets us know that this is a dominant trait versus a recessive one. Okay. So you can practice on some of these others as well. You can see here, these two parents don't have it, but some other kids do, some of them don't. So we know these parents are heterozygous and this is recessive. And you can look for other patterns. Notice in this one, mostly only males are getting it. So this might also be a sex-linked recessive disorder. So that brings us to law number 2. If mom has the trait and all her sons also have the trait, then that lets you know that's a sex-linked recessive trait. See here, only this one mom has it. It's very rare in females, but she has it. And so as a result, every single son she has it. Her daughter does not, but then her daughter is a carrier and one of her daughter's sons ends up having it. So that kind of shows you that's a sex-linked trait. Again, it's a pattern. So, hint, if mostly just has males that have the trait, you can usually guarantee that it's going to be a sex-linked recessive trait. So you want to look here and see, like, do you see anything from law number 1? I certainly don't see anything from law number 1. I don't see two parents that are the same. You see anything from law number 2? I certainly don't. Looks like it's pretty equal amounts between males and females that have it. So, are there any patterns that we're observing? Okay. Well, here's the third pattern. If dad has a trait and all his daughters also have the trait, then that lets us know that it is a sex linked dominant trait. So that means dad has it. Mom must be a carrier. All the daughters are getting it because dad's got it. And so that lets us know what those genotypes are like. Must be dominant trait. See, dominant. So as long as she gets one dominant allele, it's going to show that trait. Mom doesn't even have to be a carrier for that to happen. Okay, so here are some ones that we can practice on. We'll practice on that in a bit. Another piece of practice. Here's another piece of practice. This is from like a real actual family. Kind of get some practice with real pedigrees. And here's our EOC question of the day. Based on the pedigree chart, what should you assume about the parental generation? All right. Well, that concludes our lesson for the day, and good luck.